This is Startalk. I'm Neil deGrasse Tyson, your personal astrophysicist. I hail from the American Museum of Natural History right here in New York City, where I serve as director of the Hayden Planetarium. And today we've got a Cosmic Queries edition of Startalk with my co-host Chuck Nice.
Hey, Neil.
Chuck, always good to have you.
Good to be here.
Tweeting at Chuck Nice Comic.
Yes, and I am the director of parts of my home on certain days of the week.
Even then, only in certain hours.
Certain hours of certain days. That's all I get.
So I think today is the topic is the physics of everyday life.
Yes.
Yeah, love me some physics of everyday life.
I know you do.
Oh, man.
I've been around you long enough
the
to
physics
actually
everywhere.
hear you speak on the physics of everyday life, whether I want you to or not.
You know what's good about learning physics?
Yes.
It's not a satchel of facts.
That's right.
To be regurgitated. It is an understanding of the operations of nature.
That's great. I was about to say it is actually the understanding of your own experiences.
Yes, that or even things that are not your experience, things that transcend your experience.
True.
Physics is there waiting for you.
Yeah, that's what makes it so cool. I mean,
Yeah, but what it means is you don't have to learn every single example of how physics manifests in the universe.
Well, thank
you
God.
You can learn the foundational things and then apply that knowledge to what you see.
Yeah.
So that's the beauty of it. And that's why physics books are not the fattest books on the shelf. Accounting books are fatter than the complete works of physics.
Right? Because they get to change accounting. You can't change physics. Physics is what it is.
It's what it is and what it be like.
What it be like is what it be like. But you can change accounting all you want.
There's so many other fields where the books are just so fat and thick, and
right.
Books on human physiology, you got to learn every little. Of course, there's some systems that you learn about, you know, the circulatory system and the endocrine system and this sort of thing,
right?
And that's very helpful for new situations. But physics is the ultimate example of learning the basics,
right?
That then apply to everything, stuff you've never even seen before.
And even all of those different systems actually have some applied physics at work.
Oh, okay. Let me take you there. Ready?
Okay, let's do it.
So biology,
yes,
is the extreme representation of chemistry.
Interesting.
Yes.
Give me 1 second, please.
Biology is chemistry come alive.
Okay, now that I've just got it.
That.
It just gave me a little light bulb,
Right.
and I got it. That makes sense.
Right.
Yes.
You can have complex chemistry, but once you talk about life,
right, that's
It
biology.
earned its own field.
Absolutely.
Okay.
And life is really a collection of chemical reactions.
Correct. Have you ever seen the physician's desk reference, the PDR?
No, I have not.
It's a zillion pages, and
Okay.
it is every single medicine prescribable in the world, or at least in the West.
Is that really?
Yes.
Wow.
Yes. And
so when
the doctor looks back and you don't see what pages they're turning, they're looking at the PDR.
They're looking at the PDR.
So it's every company's medicine that gives what it is supposed to heal,
right.
what the contraindications are, the side effects, all of this. It's in this book. So all I'm saying is it's a reminder that we are basically sacks of chemistry.
Yes.
But what I'm getting at is...
Which, I mean, it sounds so derogatory when you say it like that.
Pass me my vitamin, please.
Yeah. Give it. Hey, listen here, you sack of chemistry.
We all take vitamins or some pills for some purpose,
right.
Most of us, or we eat certain foods
right.
to get the chemistry in the food.
Absolutely.
That'll, you're drinking a cup of coffee right now.
Yes, I am, which is having a chemical reaction in my brain.
Correct.
Right. It turns off a little teeny part of your brain that says go to sleep.
So there is no understanding of biology without chemistry.
Yeah.
And there is no understanding of chemistry without physics.
Nice.
And there's a kind of audacious statement, which is really nasty, but kind of true.
Okay.
After the laws of physics, everything else is opinion.
Ooh, damn. Ooh,
that's
a drop the mic.
That's
type.
a drop the mic,
Man,
and it's kind of like,
you know who made that saying up? A physicist. Clearly,
in your opinion. All right, so give it to me. We solicited these from our fan base. I haven't seen the questions yet, as usual. What do you have?
And of course, we always start with a Patreon patron.
Patreon,
because if you support us on Patreon financially, we give you a preference to.
I think they get more than that. It's not just they get their question answered. There's like a whole list of stuff.
There is. I mean,
and at one level, they get invited to our holiday party.
That is correct.
Too,
if you give enough,
is that right? Just verifying.
If you give enough money, you get to invited to the Startalk.
If you give $1 zillion.
Right. A kabillion.
A bajillion.
A bajillion. Is
There you go.
that a real word?
That's the biggest number ever.
That's the biggest number. Bajillion.
Bajillion.
That's cool. I like it.
If you're 8, that's
Right,
the biggest number
exactly.
ever.
Bajillion. My God. And really, it's like 8. It's like, there's 16 of them.
Right.
Like, that's to a kid. It's like my son. I told my son I was 30. And he was like, you're going to die soon. Right. And mind you, I'm like much older than 30. Why am I lying to my son about my age? I don't know.
Don't trust anyone older than 30.
There you go. That's it. There you go. All right. So Renee Douglas from Patreon says this. Why is the periodic table of elements not an exact rectangle? My OCD will not let this go. Missing elements or what? Who cares? It should be a rectangle. All of a sudden, at the end, she started sounding like Jerry Seinfeld. What's the deal with the rectangle? Why? Who are these elements?
Okay, then we should call it the periodic irregular table.
Right.
So I'm with her on this. Mm-hmm. There's the urge to want nature to be symmetric in its beauty.
Yeah.
And beauty in its symmetry.
Wow. Yeah.
That sentence is symmetric.
That it is. Yes, it is. It is symmetric and in a mirrored way.
Okay, so I'll give you an example. When we were filming Cosmos, one of the scenes was in a forest in Northern California.
Right.
And I'm looking at the tree. I'm from the Northeast, and we don't have California trees here.
Okay.
Our trees are kind of raggedy.
Yeah.
Kind of gnarly raggedy.
Yeah, exactly.
Compared to the mighty redwoods and other,
They don't see the trouble that our trees see. Our trees see a great deal of trouble here.
Our trees are like...
Our trees are
they've seen
grizzled.
the Northeast issues.
That's right. They're grizzled veterans of nor'easters and hurricanes and like harsh winters. You talk to a tree in the Northeast, going to be like, "I'll tell you what I've seen. I've seen
that's the old tree on the front porch.
Right, that's,
in the rocking chair.
Yeah, our trees are like the 2 trees in the 2 towers of Lord of the Rings. Just like, I remember a time long ago.
Wait, slow down. You're talking too fast.
I know, that's true for those. For the trees, yeah. Yeah, redwood trees are just like...
They're just badass. It's like, I'm here and nobody mess with me.
Because they get to grow unfettered by anything.
Plus, they have fireproof bark.
Wow.
You try to burn a redwood, it's like, there you go.
That's sweet.
Go on around, as you keep going, keep moving.
Right.
There's nothing to see here.
That's
amazing.
amazing.
Yeah, fireproof.
They need to make all of California out of redwood
bark.
Yeah.
Right. So here's my point. Some of the trees, and I'm not a botanist, so I can't identify what tree it is. Mm-hmm. The bark had striations that spiraled in one direction around the tree.
Cool.
And I'm thinking, if nature itself were symmetric, that could never happen. These things are twisting on their way as they grow.
Right.
In one direction and not the other direction, and nothing else was twisting in the other direction.
Right.
It means at the molecular level, you have asymmetries in the foundations of nature.
Nice.
Now, here's something I read, but I'm not a chemist, so I've just read this. Okay?
All right.
The molecule that you taste as spearmint.
All right.
If you took the mirror image...
That's the doublemint molecule. But go ahead.
If you take the mirror image of that molecule, make that molecule...
Right.
If you write down the chemical formula, it'll be the same. Because the chemical formula doesn't tell you how to build it.
Right.
The spirals in it. Okay.
Right.
It's just the same number of carbon, same number of hydrogen, same number of everything. If you build the mirror image of it and taste that...
Tastes like poop.
It'll taste like caraway.
Caraway.
And so this is an asymmetry in nature. You don't taste the same thing because of the mirror image of one molecule versus another. So the universe is full of asymmetries. And do you know our amino acids have a handedness to them? These are the building blocks of our protein.
Right. So there's a left hand and a right hand.
All amino acids of all life on Earth is one-handedness.
Right.
Okay? There is no life that's the other, but there's no reason in principle why you could not make it so.
Right. Yeah.
Because it would just be we're right-handed, it'd be a left-handed, just the way it spirals in a mirror. Okay. I mean, the way it spirals versus what it would do in a mirror.
Right.
So this, it's intriguing because if you find life on another planet and it has the other, it's called chirality, then you know it didn't come from us. It had nothing to do with us.
It had nothing to do with it.
Yeah,
because it's a different handed.
It's a different handedness, right?
Wow. So what is the
And
sound?
what we're not sure about is whether if you eat the other life,
Right.
because that's what all we do is eat other life.
Of course.
Okay?
Yeah.
That's what, if,
I mean, if it's not alive and you're eating it, then you're probably going to have a little trip to the hospital. Because it's
no, you
Lego.
can't. Look, the only thing we eat that was never alive is salt.
True.
Okay, everything else was once alive or
That is
derived from
true.
something
That
that
is
was
true.
alive.
That is true.
Right. So
Even pepper comes from
yeah, pepper was a
seed.
it's a plant.
It's a
Right,
seed.
right.
Oh,
Right.
Interesting.
That's why salt and pepper are not really equal partners.
No, they're not.
Right.
No. Salt is cheating. Pepper gave its life to be on that table.
On that table.
Right.
Right.
Salt just showed up.
It just showed up for the
Right.
party.
That just like white salt. No, I'm joking.
What?
That is so white as salt.
Actually, there's black salt. I got black salt.
Oh,
I got black salt and red salt.
and there's pink salt, too,
There's Himalayan salt and there's Hawaiian salt.
Nice.
It's pink salt. Yeah.
Yeah. Wait a minute, man. How racist are you that your salt is black? Seriously? All right.
All I'm saying.
All you saying is.
Another asymmetry in physics. Okay.
Okay.
Do you realize an electron is a positive charge?
Yes.
I'm sorry, negative charge.
Negative charge, right.
So now watch. I can draw field lines coming off the electron, and there'll be straight lines coming out. They call it the electric field lines, and that's fine. I have a formula that describes that. Okay. Electricity and magnetism are two sides of the same coin.
Right.
That's why we have the word electromagnetic.
That's right.
Electromagnetic. That's why we have that word.
Right.
Okay. So if things were symmetric, I should be able to find just a negative pole of a magnet. Just the same way I have a negative charge on an electron.
But you can't.
You can't.
Because the moment you have a magnet, you got to have two poles.
Exactly. So get yourself a magnet, bar magnet, horseshoe magnet, I don't care. There's a plus side and a negative side. Cut it in half. Now you have two magnets with a plus and a minus side. Cut them in half. You have four magnets, each with a plus and minus side. You cannot cut off the negative from the positive in a magnet. But you can in electricity.
Right.
That shows up in the formulas as an asymmetry in what's called Maxwell's equations. They're not symmetric.
That's awesome.
And as a physicist, you got to get over that when you first learn his equations.
All right.
So getting back to the woman's point, the periodic table of elements has a remarkable and profound level of symmetry in it. The reason why it wraps around to another row
Yes.
and certain elements line up
Right.
in columns is because the elements that line up in columns have the same mating properties with other elements.
Right.
Okay, have you heard
So
about...
you can combine them.
Right, so take carbon, for example. We have carbon-based life. You've read, if you're a science fiction fan, you'd think about silicon-based life. You ever hear about silicon?
Right, yes.
Did they just pull that out of the ether? No. Silicon sits below carbon on the periodic table, directly below it. It makes the same families of molecules that carbon does. So they're saying, if we're carbon-based life, why not swap a silicon atom in with the carbon and make all the same molecules?
Right.
And then you'd have life based on silicon rather than carbon. The periodic table of elements captures this fact in its structure and in its form. As you get to heavier and heavier elements, things get more complex. They get, and so you have entire groups of elements that all behave in the same way.
Okay.
So how you can't, you're going to shoehorn them into one column? You can't, because now they're next to each other. So you have these things that spread out underneath. There's the two, so the lanthanide series and the, so just if you go back to your periodic table, you'll see these two rows of elements not sitting in with the other rows of elements.
Okay.
And we're still discovering elements.
Right.
So,
and sometimes creating elements.
oh, sorry. And we're creating elements. We are better at nature at creating elements on the periodic table than nature is.
Wow.
Did I say that right? We are better at creating elements than nature is.
Right.
Yes.
Nice.
That's why. So we've got like 20. What are we up to? Yeah. No, about 30 artificial elements now.
Wow. Look at that.
And they're real.
Yeah.
They made electrons, protons, neutrons.
So
and they're sitting there.
That's
yeah.
cool. Oh, look at us playing God. Now, well, that was a great answer to a really cool
That was a
question.
long answer, too.
Who cares? It was fascinating. That's all. No.
Yeah. So I'm saying
We're about quality, not quantity.
So it's if you have issues with asymmetries in nature,
Right.
then you're in the wrong universe.
You're in the wrong universe.
Yeah.
Right. But I'm
Right.
sure that there is a someplace in the multiverse that is just right for you, Renee Douglas.
Oh, by the way, just a quick thing. Isaac Newton was a big fan of God,
Yes.
as everyone was in the day.
Well, of course.
So
You
it's
had
not isolating him
Right.
in particular in this regard.
Right.
But everybody was a God fan back then.
Right.
So he
God, dude. I'm such a fan. Oh, God, what's up? Such a fan, dude. Love your work.
Friend me. That's right. Okay. So, yeah, love your work. Right. So a lot of in Newton's writings, he's extolling the beauties of nature as the handiwork of God.
Right.
And in one place, he comments about the beautiful symmetry that the human form takes, left and right.
Yeah.
But he has to then say, but only on the outside.
Only on the outside, right?
Right, because the inside
is all messed up.
Right, yeah. There's some things that are symmetric, but not
right
really.
Right down to your heart, where one side is bigger than the other.
One side and is louder than the other.
Exactly.
You only have one liver, and that's
the inside of your body kind of looks like Jeff Bezos' eyes. You know
what?
I'm just saying. He's got like one tiny one and one big one.
So your organs are sort of mildly symmetric, and there's a lot of
his eyes are so weird.
And we're not 50% left-handed and 50% right-handed.
No, we're not.
Right. So there's some asymmetries going on. That's all I'm saying.
Yeah.
So he had to sort of accept that from his praise of God.
Right.
Because he assumed that God is perfect.
That there's a plan.
And God plan, and the plan would be symmetry. Same with the Vitruvian Man that is widely associated with
Da Vinci.
Da Vinci, right?
Right.
With the man with his hand sticking out left and right, centered on a circle. So the idea was your belly button, because if we're divine, then our form would be geometric. So your belly button would be the center of a circle that you could trace with a compass. And then your arms extend and your legs out would further trace the circle.
Right.
And this was the perfect human form.
Had Da Vinci ever met a human being? No. Because there's no one who fits that.
He drew it, but he didn't come up with it. It long predates him.
Okay.
So from what I've read, it long predates him. But so my point is, when you actually do that with actual people, belly buttons are not in the same place. People have longer arms, shorter arms.
Absolutely.
Relative to their height.
Right.
So you want it all to be perfect because you have a philosophical urge for nature to be symmetric and perfect.
Yeah.
And if that's what's driving you, history tells us you're just going to get the wrong answer.
Right.
So get over it. So in physics, we get over it early when we first learned Maxwell's equations.
Sweet.
Man, that was a whole
segment on one question.
Man. Oh, that ain't right.
But that's why the show is good.
That ain't right. Okay.
We could do cosmic queries forever.
Oh, you could do cosmic forever?
Yeah.
Who's the one answering the question? I'm glad you think.
Why do you think we could do it forever?
I'm glad you think we can do it forever.
It's nothing for me.
When we come back, more cosmic queries, the physics of everyday life, when Star Talk returns. We're back on Star Talk, Cosmic Queries. In this edition, it is the physics of everyday life. Chuck, I love me some physics of everyday life.
Yeah, man. So do I.
Yeah.
This is really good stuff.
Okay, so what do you have?
Let's jump right
Bring it right back.
And this is Raphael Katabak from Facebook. And
You've been practicing, Chuck. I'm very impressed.
No, not at all. You know?
All right, what do you have?
I mean, it probably says Smith there as far as I know. But anyway, if we were visited by a more advanced alien race, what do you think they will admire most about humans? And with regards to our current scientific knowledge and understanding, what particular theory or law do you think they might disprove?
Oh, interesting.
That is that's a great question.
I'd like that. So
it would have to
if I may be cynical.
Cynical.
May I? Only with your permission.
Go, please. I'm all about it's rare that I see you actually admit to being cynical.
I think aliens more advanced than us would be impressed how far we've come.
For being such dumbasses. For being such dumbasses. You were trying to find out a very diplomatic way
how far we've come in spite of ourselves.
Exactly. That's what I said.
I think they would have said, we never thought you'd get there.
Oh, that's hilarious.
Because you've been on Earth for you've had what you call civilization for thousands of years.
Wow.
And it took you 10,000 years of civilization before you even visited the moon. You could have been there a long time ago.
Right.
But let me just be happy with what you did achieve.
Oh my God.
What? Imagine if we'd landed on the moon 2,000 years ago.
No, I'm imagining right now.
Imagine if the Romans had rockets.
Yeah, but I'm imagining right now, just where we
Imagine
are.
if the Egyptians said, let's leave Earth.
Well, they did. They were aliens.
Well, that's true. They were born in.
Right.
Aliens had a thing. I saw Stargate.
There you
It's
go.
true.
Right, exactly. They had a wormhole, so we can't really. But anyway, no, think about it. Look at all the technology that we have right now. And if we were to take all of the energy that we put into trying to destroy one another and keep one another from advancing, and we were to take all of that energy and just pour it into humanity.
Not just pure physics energy, but intellectual.
The political energy that we expend.
Cultural, political, and financial capital. That we have used to destroy one another.
Exactly.
Imagine.
If just take that.
Imagine.
And it was all pointed at the propulsion of the human race in a positive direction.
You want me to quantify this?
Oh, snap.
You ready?
You've been thinking about this.
You ready?
Go ahead.
Okay. In today's dollars, you know what it costs to go to the moon in total?
No, I don't.
$100 billion.
Who are you, Dr. Evil?
Dr. Evil.
$100 billion.
Ooh, okay, so we went to the moon on $100 billion. The entire U.S. interstate system is $100 billion.
Wow.
Okay. $100 billion is 1/6 a single year's allocation of the military budget of the United States.
All right, that's disgusting.
It just is.
Ugh.
It just is.
You should have never
No,
told
I
you
used to judge that, but I stopped judging it. You know why?
How can you not judge that?
I'm going to tell you why.
Please
I'm going to tell you why.
Please, you should be judging that.
I'm going to tell you why.
Okay, you tell me, because
I'm telling you.
that's deserving of judgment.
I'm telling you.
Okay.
Okay. What are we in 6th grade?
I know.
I said it first. I know you are, but what am I? So, where does the budget come from? It comes from Congress.
Where does Congress come from?
We vote for Congress. So, what does it mean? What does it mean?
That's very funny.
That's what I'm saying. As an educator,
I got to stop judging it now.
That's what I'm saying.
Ugh.
Dude.
We're such
the collective representatives of the electorate allocates this money.
Oh my
and they all agree to it.
Raphael, you sent us the most depressing question ever.
Wait, but I didn't finish answering, so I think they'll be happy. Yeah, we would have been on the moon 4,000 years ago. Right. It would have been like cavemen next chapter 2.
Right. We would have been on the moon just going,
fire.
Right.
Fire on the moon.
Rock. Yeah.
Okay, that's A. B. I think they would be impressed with our engineering ingenuities.
Okay.
So, because that's not the laws of physics now, because they would know all the laws of physics that we know.
Absolutely.
And then some. Mm-hmm. Oh, by the way, the laws of physics is not later shown to be false. When we demonstrate a new theory of the universe, it's because it has been experimentally verified multiple times by competing factions, and we say, this is how it is. We're moving on from here.
Okay.
What can happen is you have a deeper understanding of the world that encompasses this smaller understanding that you have that works. That can happen. It happens all the time.
Right.
Okay, all of Newtonian physics got subsumed into Einsteinian physics.
Right.
But Newton is not all of a sudden wrong in all the regimes in which it was tested. So I think they'll say, not that you're wrong, oh, you think this is the full story, there's a bigger story. You got the Big Bang starting the universe? No, we got multiple bangs. We have higher dimensions. We got this, we got that, and you're just one little cog in this much larger wheel. That would be highly enlightening for us.
Right.
On a scale of learning, and this is an unheralded point of discovery in the history of my field. In the 1920, the year, going into 1921, we did not know whether spiral fuzzy things in the night sky were just spiral fuzzy things in our galaxy or entire other spiral galaxies in the universe.
Wow.
There are people alive today who were alive before we knew that our galaxy was one of only 100 billion in the universe. So the idea that you're not alone in some concept, we've been hit with that multiple times before. So the astrophysicists, we'd be ready for it. We'd love it to death.
Right.
But there's some people who are sort of happy with their contained knowledge of what is and is not.
Exactly.
But just have to get over it.
Don't make me think about something other than what I
already can think about and already can grok.
I've actually accepted this.
This, correct.
Right. The Earth is flat. That's it.
So the other part of that question, so I think they'd be impressed with some of our engineering technologies.
Okay.
I think they would like the smartphone. I think they'd be impressed with that.
Yeah.
I think so.
That's pretty cool. Even though we all know that, Steve Jobs got that idea from an alien because it was one. So, all right, cool, man. Okay, I'm going to read this anyway. Kevin Miller from Facebook wants to know this. Assuming the Earth is flat. That's a big assumption, Kevin. I just love any question that starts off with assuming.
All right, let's go there. Let's follow
the Earth, but I know
let's follow the reasoning.
One of the things I like about you is that you'll take these and do something with it. All right. When the ice melts at the poles, where is all the water going to go?
I have no idea.
Exactly, because the Earth ain't flat. No,
it seemed to me it would spill off the edges.
Right? I mean, seriously, if the Earth were flat, it'd be like a table, So
yeah, you spill some on the table, it spills off the edge.
Yeah.
I'm thinking, unless you build a dam.
So now the Earth is not flat; it's more like a pie dish.
Oh yeah,
Nice.
Yeah, it's got edges to it.
It's got edges. Mm.
And beyond there be demons.
Why do I feel like Jack Sparrow right now? And beyond there,
beyond there limits.
Yeah. All right. Well, there you go, Kevin. There you have it. All right. That's
it's a pie plate.
It's a pie plate, bro. That's all we can do for you.
All right. Give me another one.
All right. Here we go. Let's move on to Nader's 19872 from Instagram. Mm-hmm. How far away would a black hole have to be in order for our solar system to fall into it? I also have another question. Why are you so awesome? I love Startalk, and you are just one of my heroes.
That
last part was for me.
Thank you, Chuck.
Yeah, no.
No, did he really say that?
Yeah, I'm serious. He was talking to you. I was joking. Yes, he's saying you are one of my heroes, and I really love Startalk.
Okay, no, we appreciate that, and let the record show that you were reading that question, whether or not he appended it with that sentence.
Well, he didn't write it to me. So
I'm just saying.
You don't know the questions.
We don't boost questions up just because you're saying nice things.
Well, we do boost questions up if you're saying nice things about Chuck Nice, because I'm the one who's reading the damn questions.
That's true.
You know what I mean? But
so thank you for those kind words.
Okay. So now the question after the kind, or actually preceding the kind words, was how far away would a black hole have to be in order for our solar system to fall into it? I think what he means, instead of how far, how close?
Yeah. So
would it have to be? Is what he really
same thing. Same idea.
Same thing.
So that's not how black holes work.
Right.
Okay. Black hole is not some giant sucking machine. We're given
like my career. Oh, I'm sorry. I'm laughing
Chuck,
at my own pain.
We love you, Chuck.
Okay.
Chuck, you're a hero on our podcast, no matter what else is happening to your career. I don't know.
No matter how far in the toilet your career may be, Chuck.
Did you get booed off this comedy stage last night?
No, actually, a really good show.
A good show. Very nice. Very nice.
So anyway, it doesn't work.
Should a comedian be the one who judges whether the comedian has a good show?
No, yes, the comedian is always the one who judges. Okay. Because here's the great thing about being a stand-up comic.
Okay. You know.
You always know. And you can and I love young comedians because they get off the stage and they immediately lie to themselves. And they get off the stage and they look at you and they go, yeah, so that felt good, right? And I'm like, why are you asking me? It felt good. It felt good. You don't need my permission for it to feel good. You know you suck. You know you suck. What is your problem?
Chuck, the mentor.
No wonder no one comes to me for advice. All right. Anyway, back to Nader's 19872.
Black holes are not some giant sucking machine.
Okay.
So they have a gravity commensurate with their mass. Like anything, you have gravity.
Yes, I do.
The moon has gravity. Earth has gravity. The sun has gravity.
Anything with mass has gravity.
Anything with mass or energy has gravity, because energy and mass are the same. Equals MC squared.
That's right.
So you can ask how much mass does the black hole have? And if it has a planet's worth of mass, it could just hang out in our solar system like another planet.
Right.
If it has a star's worth of mass, it might accrete planets to orbit it. If it has...
Interesting.
So
it could even have a galaxy's worth of mass.
A galaxy's worth. We have a supermassive black hole in the center of our galaxy. So you don't want to get too close to it, because there are places where they're no longer stable orbits. And then you fall in.
And then you fall in.
But you can calculate what that distance is, and it's not too hard to stay away.
Right.
It's not that hard.
Right.
Otherwise,
It's not like it's a siren. Like you don't have to lash yourself to a mast and just like, I'm going to hear the song.
You're still going classical voyages here.
I am.
Oh, weren't they the Sirens? No, the Sirens.
Yes, the
Sirens.
Yes.
Yeah.
Nothing gets sucked.
So here's the thing.
It's not just sucking stuff in.
If we turn Earth into a black hole, it would be like the size of a plum, last I calculated. So, and the moon would still orbit it. The moon wouldn't care.
It wouldn't fall in.
Wouldn't care. It's only responding to the mass and the gravity that it so what makes black holes interesting is that you can get really close to them and get ripped apart and spaghettified. Okay, you can't get closer than Earth's surface to Earth's center of gravity. Okay, you'd have to shrink Earth to get closer to it. Shrink it down to a plum. Now you've been spaghettified.
Wow.
So all the interesting stuff that happens with black holes is because you can get really close. Otherwise, you're hanging out where you've always been. You are perfectly safe. Don't have nightmares about it.
It doesn't do anything to this. Like it never.
Now, if I had Earth as a plum, if I took another planet, take Venus, made a black hole and brought it here, and let go, it would fall through the Earth and eat Earth Swiss cheese style as it bounced back and forth, and it would systematically dine upon all the physical contents of the Earth until Earth plus Venus became one.
A big, right. So you'd have the merging of those two.
Yes, and it become like the size of an orange or something.
So the black hole would actually increase in size itself.
Physically.
The physical black hole would increase in size if you were to merge two black holes.
It turns out to be linear with mass. So a black hole that's twice the mass will have twice the diameter.
Wow.
Turns out, if you do the math.
Okay, cool.
And the diameter is the diameter of the event horizon.
Right.
Got to say that.
That sounds cool.
Okay, we're out of time for that segment.
Okay, once again.
When we come back, more cosmic queries on the physics of everyday life. And Startalk returns. We're back. Startalk, Cosmic Queries, the physics of everyday life edition.
All right, let's move on. This is Total Nerd 52.
Love Total Nerds.
Total Nerd.
Proud of it.
Yes, as opposed to his...
Partial nerds.
Right. Yes.
Or weekend nerds. I want the total 24/7.
I want a total nerd, not a quasi-nerd. What degree can you do more with? A physics degree or a mathematics degree?
Physics degree.
Really?
Yeah.
Now, are you biased?
Some things are objectively true in the world. Let's say it another way. In spite of what it might seem like to your parents, if you choose to major in physics or math, both of them are highly employable by people who know and understand the brain wiring that emerges for having done so.
Absolutely.
Okay?
Yes.
Mathematicians and physicists are problem solvers, and engineers are problem solvers.
Right.
They can see problems in ways others have not. And it's just that physics has more places to plug into
more
the operations of society than does a mathematician. That's all. But in either case, you don't see either mathematicians or physicists as on the street
begging. Right. Exactly.
You'll find artists, you'll find musicians.
We'll calculate for food.
That's right. We'll recite digits of pi for, no. So
for pie.
for pie. Haven't had pie all day.
Pie all
How many
day.
digits can you do? So it's a reminder that there's certain professions that fundamentally plug in to civilization, and others that become a part of civilization because we choose it to. So we embrace music. We embrace art, the kind of art that is not otherwise self-sufficient. So I'm not talking about pop music. I'm talking about, orchestral music that generally is performed in institutions that require
funding.
Right. Yes.
And that funding normally comes from someone who gives a great deal of money to make that happen.
Correct.
Because it can't sustain itself.
It doesn't sustain itself.
Through the appetite of the public.
Yet, the city in which you find those offerings of art boast that they have those offerings of art.
Right.
It's in the catalog.
Exactly.
We have this Philharmonic Hall, and we have
Boston
this
Philharmonic,
and we have this art museum, and we have all these institutions.
Right. That's what makes us a cosmopolitan destination.
Correct. So it's an interesting difference that we have art and science in the same phrase. I went to the College of Arts and Sciences at the University of whatever. The arts and sciences go way back as a paired thing. We have Leonardo as the epitome.
Right. Actually combining the two.
He's one of the greatest examples of that. So I'm just saying a society has to want to embrace its artists in order for them to manifest as a fully expressed, employed community. Whereas financial forces can drive your interest in having an engineer or a physicist on staff.
Absolutely.
For example, Mayor Bloomberg.
Yes.
Former Mayor Bloomberg.
Yes.
Okay. Successful businessman.
Very much so.
Very much so.
Billionaire.
Multi-billionaire.
Like a real billionaire, not like some other people.
Some other people you heard of.
I'm very rich. Very, very rich. Normally when people tell you they're very rich, they're me.
They ain't.
Right, they're me. Like, yo, don't look at that. I'm very rich.
So here's the thing. When he built his company,
Right.
he could have hired MBAs who know their business, but that's not who he hired.
Who did he hire?
He majored in physics and engineering at Johns Hopkins University.
Okay.
He hired mathematicians, physicists, and engineers.
Wow.
And would teach them the business side of the world, but he needed people who
Problem solvers.
who would go with gnashed teeth
Right.
and attack a problem they've never seen before.
Right, right.
And my wife was one of those earliest employees.
Get out.
She has a PhD in mathematical
Well,
physics.
I knew that. I didn't know that
Yes.
she worked for Bloomberg in
Yes.
the early days.
When she was there, Bloomberg had 100 employees.
Oh, my God.
Yeah.
She got more money than you. Now I know.
So she was early in on that, and he
Wow.
recognized what she could bring to the table there.
Interesting.
As others that she worked with. Yeah.
That's so cool.
Yeah.
Yeah. All right.
Yeah, so go
physics.
for it.
Go.
No, either. Do either. Do if you're going to pick one of those, pick the one you love and do it.
And do it. Okay, cool.
Okay. And you'll be better at it than others, and people beat a path to your door. Give me some more.
Okay, here we go. Why haven't there been a greater number of advancements on solar energy, given it's literally a constant free source of energy?
Yeah, the source of the energy is free, but the devices to convert it into useful forms,
Right.
given the economics of what is going on right now, has not yet reached that tipping point. Right. So right now, sort of the wealthy class that has the luxury of being green without regard to its impact on your pocketbook, they're the first adopters of the electric cars and the electric this and the solar panels and the like. What is missing from the equation is how much our tax money throughout the last century has subsidized the oil and gas industry.
There you go.
Okay, we built the roads, bought the car that now we put their gas in. They didn't build the roads.
That's right.
Okay, so the question is, can and should society subsidize the solar energy universe in the way we have subsidized all the rest
fuels
the
industry.
fossil fuels industry?
Yeah.
And in doing so, would that tip the economics in the favor of solar panels and solar energy?
That's a great point, man. Yeah. By the way, that was George Xenophontos, who actually
Love that name, Xenophontos. Oh, man.
Yeah. And by the way, getting a tan is free. Solar power is not.
Yeah, so the sun's energy is basically limitless.
Right.
But also you have to be able to transport energy, move it from where it is to where you need it. And solar power exists when the sun is out and it's daytime, you know, so where you're getting your energy at night.
Well, you
so
have
got to
to
be able to
develop
store the
batteries
energy.
with it.
Yeah, so battery technology is a century behind other technologies.
Right.
So there's still some
But wouldn't you see a proliferation of new battery designs and an improvement in battery life if you were to see the same burgeoning of solar power? I think one would drive the other.
possibly, except we already have a huge demand for batteries. We're using more batteries today than ever before.
This is true.
It used to be, I need a battery for my wind-up toy. No, you wouldn't need it if it was a wind-up toy.
Right.
I need a battery for my motor car. And so you go buy the battery, and then the battery would leak or it'd run out, or you leave it on. The buying of batteries was a major thing in the day. Now, anybody's house has 30 batteries laying around.
That's true.
Okay? And the batteries last longer than ever, and our machines, our devices that use batteries
Use them more efficiently.
Right. Exactly. So
Right.
so batteries, we think batteries are improving at a higher rate than they actually are because the demand, the energy demand,
energy demand for
even our flashlights are LEDs.
Exactly, which means that they're using much less juice.
Yeah, exactly.
Wow.
Exactly.
Okay. Well, listen, man. I can only hope that George, that what you want to see actually happens. You know?
Yeah. And so, like I said, it's an economics thing.
Right.
So the day that economics tips, everybody will have solar panels on every horizontal surface in their life. It'll happen practically overnight because that's how these things work. And in a free society, there's a limit to how much you can beat someone on the head to get them to spend more money for something that's almost as good or not quite as good as what they already have.
Right.
Or even if it's a little better, but if they can do it cheaper. So most people want to save the buck.
That's true. That's why I don't mind that.
Right now, you can't give away an incandescent bulb.
No, you can't.
You can't.
Because they cost you more money. I mean, if you're smart enough to know what you have.
No. So incandescent bulbs, I think they're cheaper than a thing, but if you do the math on it,
they cost you more money.
They ultimately cost you more money.
Exactly.
And you got to throw them away, and they get hot, and everything.
Right. Yeah. Well, they're really a heat source, not a light source.
Correct. They give off more infrared than they do visible light.
That's correct. Yeah, right. I think I learned that from you.
Okay.
That's how long we've been working together.
They're primarily a heat source.
Yeah, they're primarily a heat source. Yeah.
Right.
Marco Blackwell from Facebook wants to know this: with the advancements of science, has there been any attempts to change any of the established rules, laws of physics, laws of motion, thermodynamics, etc.? Or is it once that it's a law and it's established that it just cannot be changed? So, in other words,
you were like 10% Captain Kirk on that one.
I know.
Just saying.
It just cannot be changed. Tell me, Spock, what is it with the laws of thermodynamics?
Once, okay, in the old days we used to call them laws. Back in the 19th century, classical, the pinnacles of classical physics, Newton's laws of motion, the laws of thermodynamics. 20th century, we've loosened the word law. We don't use the word law anymore. Not because they aren't laws,
right?
Just because we're a little more candid about the fact that what we say is a fundamental property of the universe may be a small part of a bigger understanding of the universe.
Exactly.
Whereas law implies, there we go. But what we are discovering that is experimentally verified is not later shown to be false.
Right.
And this is a misconception that so many people have. They say, oh, there's a theory of quantum theory. That means that we won't it'll be different. No, it is working, baby.
Right.
We got this, okay? There's still some other things we can understand about it. There's still some frontiers. It may plug into a larger understanding, but the quantum theory that we have established, experimented on, and works, we are good to go. So, no, it does not change. It only expands.
Aha! So, there's the rub.
Yeah, exactly.
It expands.
Our understanding can expand on that understanding.
Right.
But it doesn't swap out that understanding once it has been experimentally verified. And at that point, it elevates to the level of theory.
Right.
So that's why I'm trying. I may lose this battle, but I'm trying to get people to not say, when they say, I have a theory about, no, you have a hypothesis.
Right.
Okay.
And it's probably not even a hypothesis. You have a feeling.
Right. Because I have a theory. No, Einstein had a theory. You got a hypothesis.
Right, exactly.
Okay.
Right. Because a hypothesis.
If you have a feeling, that's another level. I got a feeling.
I got a feeling.
Right?
Because people say I have a hypothesis, and I'm like, really? Is it educated?
Have you really thought it through?
Have you really thought it through? Because that, Okay.
We got 2 minutes left. What do you got?
All right, here's one. This is Haney.
You laugh in advance of the question. That's embarrassing for the person who asked the question.
I'm not laughing at the question. I'm just laughing at that. Okay, I'm laughing at the question. Haney Larmp says this.
From where?
From Instagram.
Okay.
What causes thunder?
Thunder. Very good.
I know, but it just seems so weird to ask Neil deGrasse Tyson.
Why?
Because you're an astrophysicist. And
it's physics, dude.
It is physics, but I'm just saying, there's so much that you are associated with in terms of your expertise.
Maybe this person knows everything else. Ooh. And it's the only gap left in their knowledge.
Oh, sure. So, right. Yeah. They know all about redshifting,
okay,
but they don't know what thunder is.
Okay.
Okay. By the way, I am not trying to disparage you, Lauren, at all. Okay.
All right.
I mean, Haney. Yeah, that's his name, Haney.
All right. So,
what is thunder?
Here you go. Okay. So, during a thunderstorm,
yes,
a rainstorm, a vigorous rainstorm,
okay,
water falls out of the clouds.
All right.
And generally, those water droplets have a net charge associated with them, a net negative charge.
Okay.
So it is separating negative charges out of the cloud and putting it in the ground.
All right.
There's a limit to how much of that you can get away with before the charges say, we want to rebalance.
We need more charge.
No, we want to
we want to uncharge.
Uncharge.
Right.
Okay? You are stripping negatives from positives, and that's not how they want to be.
Right.
Okay?
They want to be balanced.
They want to be balanced. So this builds up enough imbalanced, and it says, I'm coming back to you, Elizabeth.
I'm coming to join you, honey.
I'm coming back.
I'm coming to uncharge.
Okay, so those charges rise up.
Right.
And they come out of the ground, and they create a visible arc of light that we call lightning back up to the cloud.
Okay.
So all lightning
Comes
is either
from the ground.
cloud to cloud or ground to cloud.
Right,
It's
ground
not,
to cloud,
It's not
yes.
cloud to ground. Okay. All visible lightning. Okay.
Right.
So up comes this very hot, extremely hot
Arc of light.
arc of light. Okay.
Ooh.
It is so hot.
That when you open and look into it, your face melts. It's beautiful.
It's beautiful.
It's beautiful. Okay. Oh God, we are such nerds. Dude.
Such Raiders nerds here.
what a
Okay.
shame.
So
So it's so hot.
it is so hot that the air catastrophically expands.
Interesting.
That's what happens in the cartridge of a bullet.
right.
It gets hot,
That's why it makes a bang.
and it expands catastrophically. The bullet comes out the side. The shell drops to the ground.
Right.
Okay. So anytime you rapidly heat air, that's how a bomb works.
Right.
It rapidly heats air. That's how the nuclear bombs work. You rapidly heat the air. The air knows only to expand catastrophically at that point, and it's a shock wave.
Right.
A shock wave. So it's not just, I'm getting louder. No, it's boom.
Right.
And it's that expanding air that you then hear as thunder.
After the lightning.
After the lightning.
Right.
And it moves at the speed of sound.
Which means the lightning you always see first.
Okay, so I forgot, is it 7 seconds a mile or something? It's some number of seconds per mile. So you can count how far away the lightning is and how far away that thunderclap was from you
And that'll let you know how close the storm is.
by the time delays. I saw a documentary once, and he's very concerned about the accuracy of the thing. And he had a thunderstorm out in the distance, and you heard the lightning exactly with the thunder. So at the end, the filmmaker was there in the room. I said, why did I hear the thunder exactly timed with the lightning? I first said, do you care about accuracy in your documentary? Of course. Yeah. Accuracy is everything. So I said, why did the light... Oh, well, we shifted the sound because it was too weird.
Right, it's too weird to have them. Right, it looks like it's out of sync.
It looked like it's out
That's
of sync.
because it is out of sync.
Because it is out of sync.
Nature made it out of sync.
You know what's really cool? If you go see a shuttle launch,
Right.
Go back in time.
I was going to say,
or
yeah.
watch any launch.
Any launch, okay.
Launch. That's a catastrophic heating of the air. It's thunderous, and the closest you can get if you're a civilian is like 3 miles away. Mm-hmm. So you just see this thing take off, and it's total silence. It's total silence.
Nice.
And you see the shock wave, the front wave of the sound, move. This is Florida, so there's a lot of water
around here.
around. So you see this ripple moving towards you, and birds coming up. You still don't hear anything. It's still silent. Then you hear as it comes to you. So it's just fun to watch the sound come to you.
Nice.
It's just a fun thing to do that. But anyhow, so that's what thunder is. And because the arc is not a straight line,
Right.
it can bend. It'll take the most electrically expedient way back to the cloud.
Makes sense.
And it's not always a straight line.
Right.
It could be because it's wetter here, and water absorbs, conducts electricity better than dry air does. Okay, so what you have here is if there's angles to the lightning strike, it's possible for you to be at the focus of 2 of those angles. So in other words, if there's a straight segment off to your right and a straight segment off to your left, then you have sound coming to you from 2 different directions.
Ooh.
And if they hit you at the same time, you get the snap, that crack of the thunder.
Like it sounds like a paper tearing, or the sky is tearing.
It's an extra
Yeah.
magnification of the
It's my
sound
favorite
because you get
thunder
multiple
sound.
sound paths coming to you at the same time,
Oh, I love it.
rather than just one. It's like
Yeah.
that's this, that, all these different angles coming to you at different times. Some of them hitting you at the same time.
Cool.
Chuck, we got to end it there.
Oh man, that was a good one.
Dude, Chuck, always good to have you, man.
It's always gonna be here.
Love you, man.
Love you too, man.
Love you, Chuck. You've been listening to, possibly even watching, Startalk. I'm Neil deGrasse Tyson, your personal astrophysicist, and this brings an end to our Physics of Everyday Life Cosmic Queries. And as always, I bid you to keep looking up.